our last example here. The integral from 0 to infinity of x squared over x cubed plus 1 squared dx. This is something that should scream u substitution. And the reason why is twofold, in fact. As you can see, we've got an inside function inside of our squared. That inside function is x cubed plus 1. In addition, we've got a function whose derivative, or a variation of its derivative, is inside the integral as well. X cubed plus 1's derivative is 3x squared dx, and we can adjust that by a factor if we need to. In fact, that's what we're going to make our u substitution. U is equal to x cubed plus 1, so that du over 3 is x squared dx. Before we proceed with all that, we want to make sure that we attach our limits to the integral and say that this limit as a goes to infinity of the integral from 0 to a of x squared dx over x cubed plus 1 squared. Now we make our substitution. The limit as a goes to infinity of 1/3 of the integral of du over u squared. Now it should be noted that we need to adjust our limits, just as we talked about when we did our regular substitutions. Notice that as a goes to infinity, even with our substitution, that's still going to be the case, because as x goes to infinity, u will still go to infinity as well. Okay, so we're going to keep that part. But our bottom limit was 0, so we need to make sure that we change our limits in terms of u by plugging in x is equal to 0 and changing our bottom limit therefore to 1. Okay, so now we evaluate our limit. Limit as a goes to infinity of 1/3 times negative 1 over u, since negative 1 over u is the antiderivative of 1 over u squared, as we go from 1 to a. Plugging in our values, we get the limit as a goes to infinity of negative 1 over 3a minus a minus will give us a plus 1/3. Now we need to evaluate the limit as a goes to infinity. The a is the dominant power in the denominator, so this part of the limit will go to 0, so our answer is just positive 1/3. U substitution can be a very valuable trick if you see an inside function, or if you see a function whose derivative is also in the integral.